Okay, so this part is going to be the input. Now we know how to set data types, create variables, how to output data to the console. The next part is to read data into the program. And again, in Python, it's very simple. There's no other classes to add. You just use the word input and you're done. Very simple like that. So let's see if I go and comment this out. So usually when we import to the program, you can use the word input or the function input. And so input here, inside input here, you can put instruction to tell the user what you expect to get. So you can say enter name, for example. And then you need to assign that input to a variable. We can call this name equals that. Okay. So what this will do is it will actually put close the quote here. It's going to put a message to the console, and it's going to wait until you enter a string, and then it will then proceed with the execution of the code. In this case, it will assign the input of the string to the variable name, and then that's it for that part. We want to print it out too, so we can say print your name is, and then here, name. So if I click play, it's kind of tiny, but down here, see it's waiting. The very bottom down here, I can't move it on top. Okay, the very bottom here. What I should do, let's do this. Let's clear the whole thing. Let's stop that and clear all my variables. Just say yes. Okay. So all my variables are gone. It's from RAM. It wipes out from the kernel, that's what I say. And so now, well, I still can move it. Well, anyways. But it's waiting for the input down here at the very bottom. And I put, for example, Mark. Then it will print the message back says your name is Mark down here. And I should probably Okay, so this one here is just a string, so we're fine because that's what we expect. We expect to be a string coming in. But it doesn't mean that I can enter a different type. So if I go in there and enter instead of the actual name, I put number 123, it's a accept because it would treat that as a string also, right? Because the data type I'm expecting to be a string. But if I use that as a numeric value and do some type of calculation, then it doesn't work. And in that case, you have to convert it to an integer or a double or a float, and then use that in your calculation. So I say enter name, you got the name, you have another one here, maybe age, right? Input your age. And then this one here, we expect that to be a number. But of course, if you just do a display of that to the console, then there's no point of doing any conversion. But if you want to do, let's just say that you will convert that to a dog year or human year, however you do it. Let's say dog. Is it dog year or human year? Because a dog, well, one dog year is what, 7 human years? Oh, the other way around? The other way around? Okay, so let's just say dog year, right? Equals age times 7. So now I expect age to be an input of type integer because I'm using a multiplication here. And I put that here, so I can do another print here. You are, I could use this method, dog year, years old. Assume that it's understood. Okay, so I don't do all the other formatting. And I expect this to fail at this line right here because I'm trying to do a multiplication of a string against a number. Of course, in this case, it doesn't tell me that, but we'll see if this works or not. And so name would be like Joe, age would be, let's just say 12, and well, actually it does work. So, whoa, that's so huge though. Oh yeah, yeah. You know what happened there? It's a logic error, right? It's a logic error, and this has to do with those. And this only works in Python, by the way. Okay. If it's were in other language, it would fail. In this case, it's a good catch. What this one does, as you can see, it says 12, 12, 12, 12. If you count the number 12, it occurs 7 times. Is that 7 times? Yeah. 1, 2, yeah, 7 times. Okay. And this is what it does. This special operator is a multiplication, but if you are using that against or a string, then what this one do is that it will print or it will print or assign this n times to this variable here. And it's very useful in Python. If you want to repeat a series of input number or characters, then you use the multiplication operator to do that on a string. Okay, and you get that many times. And this is incorrectly calculated, but so this is a logic error. I did not expect to get that. I want to get a different number. So then to make this work, you have to convert this into an integer, right? Convert it first, and then now it's an integer, and then you can multiply that by 7 to get the dog here. So if I run this again, hopefully this will be correct. I put here Joe, and 2 will be 14. So here it'll be like 14 years old. Okay. So back to this part earlier here. And this is really useful in since we're here, I'm going to just show you really quick for now. Let me turn this off for now, and then I'll come back and do that part. Okay, so for example, if I do print A. Okay, if you want to do that multiple times, so usually in other languages you have to write a loop, right? Loops for 1 is from 1 to n. Say if I'm going to print 10 times, I have to loop that 10 times to do it. But Python is pretty sweet because all I have to do is just say, okay, I want to print A 10 times. And that's all you do. If I do that, I got to print A 10 times. And that's exactly what happens down here. You see that it prints A 10 times. And I think it doesn't matter the order. You could put 10 times A or A times 10. It should still be fine. And just to do it kind of quick, I can do it down here in the command line. It's hard to see if I print, let's say 5 times B. So see that it prints B 5 times. So it's very useful if you have a list, same thing, a list of 1, 2, 3. I mean, not that quote here. Then it's going to print the list 10 times. Right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 10 times. So it's very handy in that situation. Save you, I guess, 3 or 4 lines of code for looping through that list. Okay. So that was, I guess, a nice error. But I think basically that's it for the input. There's nothing more to talk about than just that. Okay. The only thing you need to do is you need to convert to the data type that you need to do the calculation here. So I'm using integer, so I'm going to get integer value, whole numbers. If I want to change this to a float, then you can put float in front here instead of int, and it's going to force this to be a decimal number. And when I run this, it's going to print, if I put Joe and then 2, oops, not here, down here, Joe, 2, you see they had 14.0 years old, because now it's a decimal number instead of the integer number. If you want to force a decimal place to be like 2 decimal places or more, then you need to format this name part here. I mean this dog year here. And so the way to do that, the easier way, is to use what we did earlier. I need to change this to the percent. It's a decimal number, so you use the F for float. Okay, if you use a D, it's going to be a decimal, meaning it's a whole number, an integer type. Float will be a decimal number. And if you want to display, let's say, 2 decimal places, then before the F, in between the percent sign, you put the dot and number of places. It's a dot 2 places. I'm forcing this to be 2 decimal place only. So if I were to do this again and put Joe 3, and you see that I forced. Oh, I didn't put the result here. Forgot to put the data. This would be dog year. Okay, the percent, and then the placeholder needs to be filled. And 3, so see it's 21.00 years. You can also truncate this if you have a decimal number here. It's more than 2 decimal places. So that's another way to format your numbers to a certain digit of placements. I think that's also part of the assignments as well. Let's see what else we need to cover here. So we got all these input. One thing that we can talk about, also very common, is let's see. Oh, before we go there, another way to declare and define variables is, let's just say you have num1 equals 12, num2 is 24, right? And you can say like, fruit is apple. You can see I declare each variable and then define or set each variable separately, and that's fine. Another way to do this in a single line is you can say num1, num2, fruit equals, and then the numbers 12, 24, apple. Okay, so you can do that, and again, just make sure each number corresponds to the correct position over here. Otherwise, you have a logic error. Okay, or if you want all of them to have the same value, you can do something like A equals B equals C equals 24. So all of them has the value 24, which is very nice, right? You can't do this in Java or other languages. Maybe JavaScript, I'm not sure. I don't remember, but you can't do that. If you do Java, you have to put, you assign here, comma, assign that, and then done. But this is a little bit different. So that's a different way so you can declare variables and define in a different way. A string, for example, if you do a string, let's just say a message is equal to, you put welcome to Python, right? So that's a single line string. If you want to use a second line, I can't do this. Right? If you do that, because of the character return, it would think that it's an error. So it would think because the character return forces that to be the end of that statement. So it's an incomplete statement. Then suddenly you have incomplete or syntax error here as well. So this won't work. Okay, so to make this work, you have to use a concatenation or this I showed you earlier, right? Like that. And if you need to do multi-lines, like you did here, then you can use 3 kind of like a multi-line comment. But then now I can do multi-lines. And you see that it's green, so that means it's legal. Okay, it's not a comment. It's I believe it's a multi-line string definition here. You can assign that to a string or message. There's just lots of ways to do it. What did I want to show you earlier? Yeah, I forgot what I wanted to show you. Yeah, just the operators. So you can see it's right. It's confusing because when I do that, it thinks it's the end of that statements. I'm just going to delete this for now. So the operators. This is math, right? Same thing, plus, minus, division, and multiplication. The two star here is a power up. Okay, so you can use these in your program. So if I do like power equals 2 to the power of 2 or 10, right? That's 2 to the power 10. That's what it means. And if I print that up, you see that that's what it should be. I'm not sure that's too large or not, but so it's 1024 here, right? So that's the power. The other one is this %, and that's called the modulus. It's very useful. Returns the remainder of a division. Okay, so if you want to do something like print 4 divided by 3, then the remainder is 1. I expect it to get 1 because 4 divided by 3, you get 1 remainder. Okay, so it will return the remainder of that division, and you see that it returns actually 1.333, but it's the remainder portion of that division and not the other part. So you can use this. It's very useful for finding like a number is divisible by another number. Okay, or in other words, finding even and odd numbers, right? So if I do 4 divisible by 2, that means that all the numbers that are divisible by 2 are even numbers. So in this case, 4 is an even number. If that's the case, then the remainder should always be 0 and exactly 0. Okay? So if 4 divided by 2 is the remainder 0, then I can say that's an even number. I mean, no, wrong symbol, sorry. It should have been the $sign. That's what I got, a decimal number here. It should be a $sign. It should be 0. So the 0, that means it's divisible by 2. If you put 5, then you get a remainder of 1. So therefore, it's not an even number. So you can use that to check that. Is 155, is it divisible by 3, for example, or 13? Doesn't matter, right? So any number you want to check if it's divisible by a certain number, use this modulus to help you, and you can quickly determine whether or not it's a divisible number. One of the classical examples is to find, maybe I'll put that in the assignments, to find a magic number within a range of numbers, like from 1 to 10,000. Find a magic number, and I'll probably throw that into future assignments. It's kind of fun. But yeah, these are pretty straightforward. It's just the power here, which some languages don't have that option here. Instead, I use a function called pow instead, and this is for the modulus. This is so True for C, C++, Java, C#, Python. Okay, any questions so far? Up to this point, we did all these operators and print, input, these data types. So don't worry about the dictionaries and the lists yet. Okay, we'll deal with those later when we talk about arrays and get the list part, because those are very powerful. It has some really powerful built-in functions you can use to, find a range of numbers within a list of numbers and so forth. So it's really powerful. And other data types we didn't talk about are things like sets. Okay, a set of numbers or a set of data is almost like a list, except that you cannot have duplicates in the set, right? So that has a lot to do with more complex data structures, but also very powerful. Okay, if you don't have a question, I'm going to just go over the homework assignment just to kind of explain to you what needs to be done. So in the Unit 2, and the practice, it's pretty straightforward here. So all you have to do here is basically write the code for these pseudocode. Okay, I kind of already give you a lot of the clues already. So you can name whatever file name you want. It doesn't matter, but the code should work. And these are the variables that I expect you to create. Anything else I did not mention will be, you can call it whatever you want. Or if you want to change them, that's fine too. Just make sure that the result would work. Okay? So that's part 1. Part 2 is kind of the same thing, except this one you are calculating a postage stamp. I think kind of similar to what we talked about in class. So this is just the lab assignment, because it gave you all the instructions already. Now the other part, the apply, is you just have to do deliberate thinking here, but it's still pretty easy. So part 1, you just write a program to convert like a number of inches to feet in inches, right? Pretty straightforward. Okay, if I give you 86 inches as the number, then you should convert it to say 7 feet and 2 inches. Okay, anything above 12 inches will be 1 foot, right? So make sure you convert that to the correct numbers and so on, and save that as this file, inches to feet.py. Again, I think this doesn't really matter. What matters is your actual program. Make sure it works. Okay. The second part is, I think the book also has a related example, but all you have to do here is find the number of denominations for a certain number that you can, abstract from that number. Okay, if I gave you a total of $58, how many of these bills can you get out of that? Okay, not per each, but the total as a whole. Okay, so you're going to go from the top largest to the smallest. So $58, I can use one $50 bill, and then I have $8 left, so I can use one $5 bill and $3 bills. Okay, so the rest will be zeros. And then the same thing here. So the last part, example, I'm using everything here, right? So 588 takes $500 bills, 150, 120, 110, 15, and then 13. Right?
So we're just writing a program that solves those three exact things.
No, it should work for any number.
Well, of course, yeah.
Yeah, but basically that's it. So if you input any number, it should work for any number you put in. Okay. We don't do the pennies. I could go down all the way to the pennies, but I mean that's too much. So that's basically what you need to do, right? So again, I did not do that a lot in my code, but make sure you comment your code. Okay. So explain what's going on in your code. If it's one thing I didn't talk about is how you name your variables. Just make sure they are meaningful. If you have very meaningful names, then you don't need to do any explanation, right? If you're using n and a or b like this, what do these variables store? Because I don't know what they are. It's just arbitrary variables. But if you say this is age, this is GPA and grade, then yeah, there's no need to explain what they are. If it's very vague, then you have to say, okay, A represents something, something, and so we know what they are. Okay? So don't overdo comments either. I see students, they comment every single line. Okay, that's too much, right? Overdoing it is going to kill your project. It's really hard to read. So just do when you think that something is need to be explained. It's very common when later on when you write functions, then you need to explain what's going on inside the function. Or a block of code is doing something, you need to explain what's going on, so we know. Not only for me, but for yourself. Like 6 months down the road, you come back and look at your code again. What the heck did I do here, right? You have to go and retrace your code again, so that takes a lot of time. So make that a habit to comment your code as you code, and which is why we talked about pseudocoding in the beginning. If you put pseudocode there, then that's already helping you part of the halfway through there. All right, any questions? If not, I think we can call it a night. And so next week, read chapter 3. We'll do functions and get a little deeper and deeper into Python as you get into the next couple of chapters. So if you have any questions at all, please don't hesitate to send me an email. And I'll be happy to assist any way I can. Otherwise, have a good night, try safe, and I'll see you next week.